In this lesson, I would like to talk about controlling the flow of operations, basically ordering the computations and talking more about the yellow cables. As we've seen previously, we know that there are different colors in cables, green, purple, pink, and so forth. And you also know that there is this yellow trigger cable, but it doesn't represent a data type. It represents a way of executing things. So let me demonstrate. If I go back here and create a main loop, as always, let's say that I want to create a simple text, as we've seen before, right? So I'm gonna create just a text mesh. Here, I'm connecting the text. Now, all good. Now the thing is, let's say I want to write a second text next to it. I'm gonna copy and paste it. And I know that I need to connect the yellow cable as well. So I have two choices here. Either I say, okay, I'm gonna write one text and then the other. And I'm gonna call this hello. And they are on top of each other because they are not transformed, right? So if I put a transform here, I'm gonna be able to move the second text around. Maybe I'll put it, here, for instance. And notice that from the main loop, first I execute the text mesh, the cables, and then I'm transforming and writing the hello here. I could have done something else. I could have also disconnected this with right click and connect everything to the main loop. But now we have an issue. It's not technically an issue, but it's something that is a bit unclear. When I have one cable that splits into two, which of the branch here is executed first? And it's not really it doesn't really relate to the position in space because I can move the cables around, and it's the answer is that it's executed in the way it was first connected. So the first was this one and then the other, but it's not very convenient because now if I start to move the patch around and I make it bigger, I don't necessarily remember. In most cases, it doesn't really matter, but we need a way to be able to know exactly which branch executed first and then the other. And to do that, I would like to introduce a very handy node called the sequence node, which is very simple. It says whatever you put here as input is executed back in order. So let me demonstrate again. I'm connecting my main loop here. And now I'm saying, okay, I'm gonna first execute this path, this branch here. Then when this path is finished, so it goes to the end of the yellow chain, I'm going back and I'm executing this other path. And the different inputs there is exactly the same. If you have, technically it's not good practice. I mean, in actuality, you would do it most often, but to have something like this, or you connect two yellow cables as input, this is perfectly valid, but it could be unclear. So the way to mangle the thing here is to connect at the input of sequence. It's really symmetrical in a way. So here I have my main loop, and I'm not really sure what is executed first. So don't forget, we have the flow mode. If I press the F key twice, I see this kind of animated cables. So I can start to see the flow of operation. So now I know for sure this one's first and then this other branch. So this is very important. And you can definitely also connect sequences to sequences. So let me demonstrate again. I'm copying and pasting here and say, okay, I'm gonna work in this area first. And so maybe I'm gonna show you how we can limit or play with the triggers. As we know, here from the main loop, it's refreshed as fast as my computer and screen allows to. So in my case, it's 120 FPS. Maybe for yours, it's 60 or even more. And now, let's say that I only want to trigger something once. This is being run continuously, but there's many cases, especially for initialization, or I want to trigger something only once. So this is an op here, trigger once. And before connecting it, we need to see that it's executed. So I'm gonna show you another op called the trigger extender, which is the simplest way of just breaking a cable into to reorganize visually. This doesn't do anything. It's just propagating the trigger here, but it's a way to move the cable around instead of having to cross the cable like this. If I want to make a straight line, I can make a trigger extender and then continue my cable here. But I'm going to use this to show you how it's being activated. So first I'm connecting my trigger once, and this was actually already triggered and we didn't see it yet. So I'm connecting to my trigger extender, and as you can see, the flow of execution stops here because this guy says, hey, trigger the following children once. If I want to reset, I can click on the button and pay attention to this cable. It's going to light up. Maybe you saw it. This has been executed only once. Very handy for initialization or for when you need to call an external API, for instance. So it's a way to limit the flow of operation. We have many ops to do this kind of things. Let me show and demonstrate another one. For instance, this one called env trigger. It's very simple. It says you decide how many time you want the trigger to go through. So instead of having every 120 times per second here, every fifth trigger I'm going to output. So I'm going to put this here to demonstrate. And maybe you see this blinking, right? It's supposed to basically blink this amount of time divided by 5 or 10, right? So if I say 10, and you notice that the refresh rate here is not really proportional to, like what you see on screen is not really actually showing what happens in reality, because it would be too heavy on the user interface to show this. So this is, let's just think of this as a way to understand that something is happening at a different rate, but don't get this blinking at face value, right? Because if I put 2, it should be even faster, but it's so fast that now we have this kind of continuous line, right? But it's a way to limit how many times the trigger goes through. I also can show you this trigger limiter, for instance. And here it's about milliseconds, in fact, time. And I'm saying here, hey, I only want this to trigger every 2 seconds, for instance. So here it's in 2000 milliseconds, it's 2 seconds. And now you should see this cable blink every 2 seconds. Maybe you see it. Also very handy to refresh something, to make sure that a scene is you know, every 2 seconds an animation appears, for instance. This is one way of doing this. We'll see in this lesson another way, but I thought it was quite interesting to start to see how we can control the flow of operation by like limiting stuff for now. Now let's say that you want to, a very common use case is to transform an impulsion, basically a trigger, into a Boolean value. Like, was this triggered, was this true or false? And it goes back to what I was saying previously about Booleans being used everywhere, but not necessarily constructed from a number. So the way to do this is to have a trigger Boolean. So this one says, okay, you can be either check the output here, true or false. So I can here use the UI to click, but if you want to incorporate this into a project, I can connect this connected to at the end of a trigger. So let's say here I'm connecting this Boolean, and I'm going to visualize it with the visbool here. So this was already triggered. Let's by default this is false, and because this has not been triggered again, it stays false. Now if I go on my trigger once and I reset, this will be true again, right? Because this is being triggered, and then I'm triggering here the true value. So I'm setting the state now of this output to be 1, true. If you want to also transform this into a string, I didn't show you this previously, but it's also could be handy, bool to string. And it's the same. If I press on a button here, I can connect and you know, visualize the output true. Let me reset this. So if I press here, it will go false, and if I go there, it becomes true. Okay, so this is I think interesting, limiting the triggers and transforming a trigger into a Boolean. Now let's try to do something a bit more interesting. We're gonna keep this on the side. We don't need to delete it, But what we can do is to start making shapes and try to switch between shapes or animate between the two. So I'm going to delete this, and I'm going to continue having another sequence, because this is my main sequence. And now I can, for instance, here decide to create another branch. So let me just start again with my trusty cube. So I'm going to put, as we know, Lambert material there, and I'm going to put a cube. Connect the two. All right, I have a green cube, all good. Now let's say that I want to basically block the flow of execution. Here everything is connected to the sequence, so that's always being run. What if I want to activate and show the cube only on mouse click, for instance, any kind of event? I will need a way to block. So of course I can here disconnect the cable, but the project needs to have all the cables in place. So the way I can do this is to add another op, and I'm going to show you another trick. If you want to add an op between two things and you know that it works, because there's one yellow, for instance, one input trigger and output trigger, you can just click with the left click and put the op, and it will be put in between if possible. So this one is called gate trigger, and it allows the trigger to pass only if the gate is open. So here now I have a Boolean again that allows me to block the flow of operation, to say no, it doesn't go through, or it goes through when I activate this. So it's very simple, but it's very common that you, especially to debug, if you have a large scene, that you use that to try to disable some of the things in your scene. Also to look at performance, you want to measure which of the of your branches from your main sequence, for instance, takes the most amount of time or resources, and so forth. If you want to simply trigger, here we can do this with the UI. Another op that might be handy is called toggle bool. So a toggle is something that just goes on and off. So it's basically swapping between true and false. And here I'm connected to my gate. By default it's false. If I trigger it, it's true. Trigger it again, it goes false. So it's just a nice way for me to click on a button. It's a bit equivalent of going back to the UI here and unchecking, but it's a nice way for me to show you another op that might be handy. And another way also to be able to transform the other way. Here we transformed the trigger into a Boolean, but what if you want to do the other way? You want to take a Boolean and you want to transform it into a trigger. You say, hey, if this became true, for instance, so trigger change true or trigger change false. We have many things for triggers. If you just type trigger here, it's like all of the things that are related to triggers. We're not going to see all of them, but it's I think you will get quickly the gist of it. So here it's the other way. It's very common that we use this. It's a Boolean that you get, and you want to now transform this to an impulsion, basically. When this becomes true, execute whatever is below once. And for instance, I can here count how many times this has been triggered with something called a trigger counter. So by default it's 0. Each time I'm going to flip the switch. Now check it out. I'm going to print the number. By default it's empty. Now if I trigger this is false, so this is not activated. I'm triggering this again, becomes true, starts to count. And each time I click, I will start to increase my trigger. So each of the ops in isolation doesn't really make sense, but I think it's really, really important to see how we can organize this. It's something that when you open someone else's patches, you don't necessarily understand all the flow of operation, especially if there's a lot of cables that goes everywhere and crossing. So by seeing like the most common things, I think you will be very confident in organizing your patches and try to sequence and organize things, which is the bread and butter of cables, because in most cases, the computer doesn't have enough resources to display all of your scenes at once, and it doesn't actually make sense visually. So you want to be able to disconnect or to disable some of the branches to only run what is needed. And the way to do this is to have the combination of all the things that I'm showing you here. Something that I talked about also previously was the use of the Boolean to do the comparison, like to create a Boolean by comparing numbers, for instance. So I would like to introduce something that is used, I would say, in 90% of all projects in Cables, and it's an essential tool to master. It's a simple timer. So a timer is very silly, but you can, as you will see, you can make very powerful things out of this. It's just something that counts the number of seconds that has elapsed since we loaded the patch. So if this is 13 seconds. If I reload the page, it will go back to 0. If I reset here, it also goes back to 0. There is also a speed parameter here, which is just a multiplication of this number. So if I put 10, now it counts 10 times faster, basically. Okay, let's keep it at 1. We can also have this at 1 and just have a multiplier after. It's exactly the same. Now let me show you something. We have a cube here. And by the way, there's also other shapes. I'm always using a cube, but let's use a triangle instead, just for the sake of changing things. So I'm deleting the cube. Now, another way to control the flow of operation using our timer would be to compare the value of our timer and say every time there is a even second, like is something that I can divide by 2 and it's even, basically. I'm doing something, otherwise I'm doing something else. So it's something that is very, very common. You could do a bit of the same thing, or counting the right now the date and time of your computer and say every even days I will show a rectangle or a triangle, and on odd days I will rotate it. It's anything you can think of, basically creating this kind of state to decide whether or not to do something. So we had this gate trigger, but there's a way to, if you know that you have two states, it's not like only activating or deactivating a branch. It's also, if something is true, I will activate this. If it's not true, I will activate this one, for instance. So I can say, if this is true, I'm showing the triangle. And I can say, okay, if this is true, I want to rotate a triangle. So I'm going to put here a transform. And I'm going to rotate my triangle here. I think it's a rotation Z, like this. Okay, so let's say 45 degrees or 30 degrees. I don't know. We decide, right? 90 degrees. Okay. So if it's true, then I'm rotating my triangle. If it's false, I also want to show my triangle, but I don't want the transform. So I can do this. And to be perfectly clear, I can, instead of having, as I said before, two cables that going into one triangle, I can do this. And now, if I execute this, true, if I show the flow of operation, and this is triggered here, I go through this transform. If I disconnect here, I'm executing only this branch. So the flow mode it's incredible to have to visually debug things. If you just program using text programming, regular programming, you don't really have this. And it starts to get tedious when you have many states to take into consideration. Here it's very visual. You see, okay, this branch is executed, so I'm not going through the transform. If this is true, then I'm going there, and then I'm executing and I'm drawing my triangle. Now, instead of clicking on and off here, I can use, as I said, my timer. And how would you, from a timer like this, counting, get basically true or false values, 1 or 0? So, pause the video, think of this. The way to do this, the most common way that we use all the time, is to have this operator that is called the mathematical operator, called the modulo. Modulo looks scary. It outputs the reminder after the division of one number by another. So why do I need to output the reminder after the division? But think of this. If I have a modulo 2, a number is either even or odd, right? So let's say here I have 10 modulo 2. 2 times 5 is 10. So the remainder is 0. 11 is 1. And any number that I would put is either a multiple of 2 or not. So it's always, the remainder is always 0 when it's a multiple of 2 and 1 when it's not a multiple of 2. So by just putting the right number here, I can always make sure that my timer here, for instance, will never overshoot a certain value and count and then goes back to where I want it to. So let me demonstrate this again. I'm dragging and I'm going to create a vis graph this time. So you start to see, and after 2 seconds, it goes back to being 0 and it counts. Check it out. Right? And because this is a floating point, it counts, then it goes back to 0. If I now put 1, it will only, every 1 second, it will go back to 0. So it's pretty cool, but it's still here a floating point value. It's not really suitable for a true if-else value. So how can I transform this floating point into just a regular 0, 1? Well, I can just round it, right? I could say, and go back here, putting modulo 2, and now I'm saying if I floor this value, floor the value means only taking everything that is after the comma, I just ignore it and I take the value before, right? So I'm just taking the integers part of my modulo here. And let me now also plot this as well. And notice that the yellow cable, like the yellow line here is basically showing the floored value, is always counting. The slope is very steep because it only moves from 0 to 1. And now with my 0 to 1, this is a suitable value for my if and else value here. So I can connect this here. And now every second, I'm swapping between the two states and I'm rotating my triangle. So I'm also like showing you how to, I think you understand, this is the basis of all animations and all other software as well. It's not cables. It's always something with time. And by just converting a simple timer that counts to, with the modulo, I'm basically transforming this value and making sure that it can never overshoot something. And then flooring the value, I transform this into a 0, 1 value. And then, so it's like a Boolean. It's better than me toggling in and out the if true here. And you understand that the number also acts as a Boolean. This is why in cables, the cable is green, because it's the same as a number. It's a good demonstration here. Of course, we could have put something else. You could say, if the value of the timer modulo 3, so for instance, every 3 seconds is above 2, so every 2 seconds, I create, I don't know, any kind of state. I could say less than, equals, and I'm showing you just how we can compare values here. Less than, I have a greater than. So if you do programming, this should be very familiar. You can be equals. I just want to check exactly when a value equals another one there. And all of these will give me Booleans that I can play with. I also have greater than equals. So the opposite of strictly less than equal is greater or equals. And I also have a specific one between equals, which is just a way of piping two operations. So if it's between, 2 is between 1 and 3, yes, I have a Boolean as well. So by combining these operators with numbers, you can really start to create cool animations. Okay, now there's something that we also use very often in cables patches to sequence scenes itself. Because I'm using the word sequence, but don't forget, sequence here in the cables term is executing all of the sub-branches, like the child branches. But what if I only want to execute one or the other, like not all of them at once? Well, there's another op for that, and it's called route trigger. It's like a route, you're driving and you take one or the other direction. So to connect this, I can also have it there on my sequence. And so how this one works is a bit different. Notice first the output is called next trigger, so the first output will be always executed. So this is not depending on the number that I put here. And this is handy to make, if you basically want to continue drawing your triangle, for instance, but then have these other triggers to modify the state of transform them or rotate or things like this. But if you only connect to there, it's like the route trigger is a no op. It means that it goes through without using the operation, the route. But we can, let's try to, I don't know, draw something else and combine both our triangles and another shape, for instance. So maybe I'm going to move this one a bit to the left. Sorry, position X. I'm moving it, yeah, somewhere here. But no, I don't want this to be moved in both cases. So it's not this transform. I need to add another transform on top of it, so that to make sure that it's always being pushed. So irrelevant of whether it's rotated or not. So here, move it this, yeah, -1, that's good. Okay, now I'm here going back to my route trigger and before, so I'm just creating a no op, and I want to draw, maybe you don't know this one, it's called triangle sphere. Triangle sphere, so it's a sphere made of triangles, but if you have many iterations, it almost looks like a sphere. But wait, it's not shaded, right? So we don't really see any kind of depth. So first let me transform it a bit and maybe put this on the right. It's a bit big, so I'm gonna also scale it down here, for instance, there. And I'm also gonna copy and paste the material, as we know. And instead of green, maybe we put it white. And so they have many iterations, so the more I put, if I put 8, it really looks like a really cool sphere, very sphere. But if I just put 2, we start to see the edges. And if you put the flat mode, it's basically a way to play with the normals, which are how it's a vector that reflects the light and tells the GPU. The GPU uses this vector to compute whether it should interpolate the values at each triangle here, each point of each triangle, which is called a vertex. We'll go back to this when we touch on geometry, don't worry. But if I put it flat shaded, now I start to see all the facets of my sphere, which is what I wanted because I think it looks a bit cooler. If I draw or undraw, this is just to disable the drawing. But so notice that my route trigger doesn't do anything because this is always being run, right? Now, let's try to play with some new operations of things that we just learned to also play with the transform, for instance. So what we can do is to first start to have different paths to execute. We could say, for instance, I'm going to use my trigger limiter that we saw here to recreate a counter. I mean, I can count with a timer, but I want to show you here that I can basically recreate the same behavior using this other technique. And you will decide in your patches which one is the best. I would recommend the timer for most cases, but keep in mind that the timer is really counting since the patch has been loaded. It has nothing to do with when the main loop or when of the trigger has been executed. So in both, depending on your cases, you want to always use the main loop as your source of truth and counting, or have an external timer which is basically not tied to the cable's execution loop. So I know maybe it's a bit difficult what I'm saying right now, but we'll see more examples of when you use one or the other. But let me demonstrate right now. First, I'm going to create a trigger limiter. As we saw, right? This trigger limiter, I'm going to connect it to the first here route. And by default, this is switch value 0. So this is going to be executed. Now, if I put something on the next to it, let me show you with the trigger extender, just for you to see. If I connect this here, nothing happens. But if I switch to 1, now only this output is being triggered and this one is being not triggered again. This is the route, right? I decide which direction I want to go. So once again, if I want to move, instead of manually switching between 0 and 1, what I can do is to show you another op called trigger Boolean, which I think we didn't see. We saw toggle Boolean, but not trigger Boolean. It's kind of the same. It's just like here, me checking whether I'm pressing true or false. let me demonstrate with the visualization here. Here, by default, it's at 0. And to be perfectly like perfect and not cheating, we should also convert our Boolean to a number, because the route trigger accepts a number. It could be any of these. I'm just using 2, so it's either 0, index 1, but it could be index 10, right? I'm just using this as a way to, because we only have 2 outputs here. When I'm clicking true, now this activates, and we can see that, hey, yes, it's true, I'm really outputting trigger 1. If I click false, I'm going back to this trigger limiter, output 0. Right? So let's start to do something with our trigger limiter. It's going back there, up. What I would like to do here is I have a trigger limiter that counts, let's say, every 2 seconds, and I would like to count how many times this has been triggered. And we know we have the trigger counter, but I want to show you how to can recreate also this behavior. There is an op called add up. It's very simple. You start with the number, it's 0 by default, and each time I click add, it adds it. The trigger counter is basically counting and incrementing from 1 to 1, but here I could increment from 10 to 10. So it's a bit equivalent if you put a multiplier, but I want to show you many ops so you start to get familiar and comfortable with the different options that we have. So I have my trigger limiter, and I'm gonna click here, add up. So technically, if I print this now, every 2 seconds, this increments. And here I need a way to reset. Right? I want to go back to 0. So how would I do this? So I need also to have a kind of a way to trigger this. So we have many ways. We could use our simple trigger Boolean, transform this to an impulsion, and say, hey, when it's true, when it's true, basically when I go to the other branch here, I reset this trigger, for instance. So how would I do this? I could say, okay, now I have something that's called trigger on change Boolean. And I created this convoluted example to show you all the possible ways of changing stuff. So bear with me and go slow. But I wanted to show as many ops as possible. So here I have this trigger on change Boolean. So this is the other, it's really the opposite of this one. If this is true or false, it will trigger either this branch or the other branch. So if this is being triggered, it means that I go to the right side here. So this should be reset to 0. So if it's true, I'm gonna click on reset. Let's see if it works. I'm here, look at the route trigger, I'm switching, this is triggered, this is reset, it goes back to 0. All good, right? So this counts only when I am in the right branch. I'm going to click again, true, and this will start to count. If I, sorry, false, go back to 0, and now we'll start to count. Okay, all good. I'm saving my patch. So now I have a way to count things. I could use that to transform, to start to rotate my sphere, for instance. So let's say I'm taking this value here and I'm connecting to rotation Y. So now I should see every, and maybe 2 seconds is too, let's say 1 second, right? 1 second. So now this, every second it changes and it rotates from 1 degree, which is not really big. So maybe we should add the multiplier here to make it bigger. So I don't know, we want to multiply by, let's say 23 degrees. And now we start to see our sphere, triangular sphere, being rotated by this counter. Okay, good. So I think this branch is okay. Now let's focus on the other one, for instance. And here now I'm gonna use the timer because we talked about this timer. So I'm gonna copy paste, and later on I will show you how to reuse the same timer, because it's not really good practice to have many timers around. So it's better to have one and to draw a cable. So either I can do this, I'm just copying here so I don't have a cable that crosses. But when I'll show you how to cut cables, we will not have this issue anymore. So just wait for the future lesson. But for now, 2 timers is okay. So now I'm using this timer, and I will need to do something with this branch. So I don't know, I can say that I'm using the timer again and I'm multiplying the timer by the same value, 23, and connecting this to my transform. So once again, here I have two cables that arrive into one input. So you say it's okay because only if we basically activate the timer only on one branch would be fine. But here they're both running at the same time, so it's a bit glitchy. So we need to either play on this branch or the other one. So how do we do this? But we basically need to stop the timer, to reset and to uncheck this, so make sure it doesn't run and only this value is being updated, right? So what we can do is to transform a trigger that we have here into a Boolean. And this we know how to do because we have trigger Boolean here. So if I'm putting my trigger Boolean, I can say, okay, when this is activated, so this is true, then it's okay, I'm gonna play the timer. And here it's not activated, so the timer should be play 0, so it should be false. Now, if I want to reset the timer as well, because I wanted to start at 0, because here let me show you here, if I play and go to this branch, my timer is counting. But if I want to switch back to the other one, well, the timer should be not counting, so I did a mistake here. Should be false, so let me just try to set it again, and I also made a small mistake. So my issue here is that I'm using this branch to reset the timer, but if I'm running on this branch, I don't need to reset it. I can only reset it when I'm on the other branch. When adds up is counting, then my timer needs to be reset to 0. So it's not here. What I need to do is to take it from here. So to make it perfectly clear, what I'm gonna do here is to create a sequence and say, okay, when this branch is being triggered, I'm resetting my timer. So it will never count. It's not activated and it's being reset to 0. And now, when I'm playing the right branch here with true, then it needs to count. So if I go there false, it resets, true, it counts. And you see it's either one or the other. Let me show next to here, going back to my trigger here, true, false, and it starts to count. But this one, as being a timer, is smooth. So now I can connect it back to my transform. And you will notice that either it moves in a big rotation all at once, or if I switch to the other one, it will go and smoothly rotate. So as I said before, it's not actually good practice to have two cables going into an import port. So the same way we have a sequence to have many inputs into one port, we also have sequence for any data type that there is in cables. So I can do sequence, and I know it's a number, so sequence number. And it's a bit cleaner, so I'm gonna do this. I'm gonna connect here, and this one there. It's exactly the same thing as a trigger. So now I make sure that I don't have two cables coming to the same output, same input port, sorry. And now I think we have it. We have what I wanted to show. We have both ways of counting and creating some kind of a moving value, either by taking the main loop and limiting the trigger and having some kind of counter, or by using our trusty timer. And the way to trigger either branches here is to use the route trigger with true or false and activating the other branch. So I know it was a lot, and it seems a bit daunting at the beginning, but it's really the bread and butter of cables. If you master the triggers, then nothing is scary, because if you think about it, all type of animation or being able to switch between things is always going to be calling or not a block or a function. And the way to call a function is to have a yellow cable, basically, in cables. So I hope this was informative. And I will see you in the next lesson. We'll talk about loop and arrays and see how we can basically combine together the data types that we saw previously and the control flow to create moving cubes and cool looking visuals. I'll see you in the next one.